Hello everyone, welcome to this video tutorial on mathematical operations with arrays. This is a part of course Applied Mathematics Lab at MIT Academy of Engineering, Pune. These are the learning outcomes of the video. After this video, you will be able to perform mathematical operations such as addition, subtraction, multiplication, division on arrays, and you will be also performing element by element operations on arrays, and you will be using built-in functions to analyze the arrays. So let's start with addition and subtraction. The operations addition and subtraction can be used to subtract two arrays of identical sizes or to subtract a scalar from an array. So let's see how does this work in MATLAB. Okay, so this is a MATLAB interface. I have created a script file to perform this task. Let's start with this array of random numbers. So before going to the addition or subtraction operations, we'll be studying some syntaxes to generate the random numbers or arrays of random numbers or vectors of random numbers. So let's start with the single value of a random number. So if we have to generate a random scalar from a uniform distribution in an interval of 0 to 1, you can use this syntax rand. So how to use this? Let's say a variable, we'll give a variable name called as number is equal to rand, and if we'll run this cell, you'll get a number. Now this will give you a new number from 0 to 1 interval or 0 to 1 close interval each time we will run this program. So you can see here the number has been changed here. The number is changed here. So this is the random scalar generation from this uniformly distributed interval of 0 to 1. Now if we want a matrix of n by n matrix of uniformly distributed random numbers, the syntax is like this. Now if we have to generate an array, I will name it as R and A is equal to RAND, and will generate a 3 by 3 matrix. So this is 3, and if we'll run this thing, you'll get array a random array of a randomly generated floats which varies from 0 to 1. Okay, so you can see here. Now if I'll run this again, it will give new set of numbers. Okay, now let's move to the next point. We'll generate a 3 by 3 matrix of uniformly distributed random integers from the sample interval -10 to 5. The syntax is like this: array is equal to RANDI. In bracket we have to provide the interval first. So this is the start of the interval and end of the interval. Then we have to give the number of rows and give the number of columns. So let's do this once again. So we'll do this for AR underscore B. This is the new matrix, and RANDI. So this will be for the integers. Now initially we have to provide the interval. So interval is -10, 5. Then we want a 3 by 3 matrix. So this will prepare a array with integers randomly selected from this interval, which is uniformly distributed. Okay, now if I'll run this again, it will give me a new set of numbers in the array. Now what if I have to maintain the same numbers in the two arrays? So I want an array B with these three numbers, with this set of numbers, and a new array with same set of numbers. Now let's go to the next cell. Control the generation of random number. This we called it as controlling the generation of random numbers. The syntax goes like this. So we'll start building it. Now you have to give a variable, let's say s is equal to rng. You have to define this thing first, then we'll start array 1, let's say array c, arr underscore c is equal to randi, and we'll give the interval, let's say this is -20 comma 20. Okay, and we want 3 by 3 matrix. So now to maintain this these numbers, we have to redefine this rng and the variable name s. Okay, and then we'll create new array, that's array d is equal to, now randi, that's integer. Now we have to define the same interval as we want same numbers and of 3 by 3 size. Now if I will run this thing, you can see here array C having integers like 6 to 9, this is 6 to 9, -161, -161, and 6 to 20. This is how you can control the generation of random numbers if you want to reuse them. Okay, so let's move to the addition and subtraction. Now we have 4 arrays, array 1 or array A, array B, array C, and array D. Array C and array D are same. So we'll do some operations, mathematical operations on this thing. So let's start with the arrays of same sizes that we have. All these are of same sizes. Now arr underscore C, or we'll do addition. Addition is equal to, now we'll select array A plus array, let's say C. Okay, now if we'll run this thing, so it will add the elements of A with C. You can see here. Now this is the element by element addition. You can see here 6 plus 6, 0.6476 becomes 6.6476. Okay, so this is how addition will work. We'll try the subtraction as well. Is equal to, now we'll subtract array B from array D. Okay, now if I will try this thing, I will run this thing, you can see we got a subtraction. Now what was the A and D? So sorry, B and D. So -6 it will become -12, then -2 and -2 will become -4. So this is how it's working. Now you can see here -1 minus -1, that is -1 plus 1 become 0. So this is how it will add element by element or subtract element by element. Now you can add that scalar value to the matrix as well. So we can do this thing, array underscore addition scalar is equal to, now we'll add 3 to the matrix, this subtraction, and if we'll run this thing again, you can see here. So the subtraction is array subtraction is -12 for -14, and if we add number 3, it will add number 3 to each of these elements. Let's say -12 plus 3 is -9, -4 plus 3 is -1. So this is how addition of or subtraction of the scalars will work, and the addition and subtraction of these uh, arrays of identical sizes will work. Now next is the next thing is, so we have completed this, we have array multiplication. As all of you know that we perform a multiplication operation using the symbol in MATLAB, and array multiplication is also done with the symbol, and it is done according to the rules of linear algebra. This means that if A and B are the two matrices, the operation A star B can be carried out only if the number of columns in matrix A is equal to the number of rows in matrix B. So this is how it works. So we have a 4 by 3 matrix and 3 by 2 matrix here. So the multiplication will be done like this: A11 into B11 plus A12 into B12 plus A13 into B31. So these elements will be multiplied with this, and the product will be summed together. So this will become the element number 1 for the multiplication matrix. So this is how it will work, row by row and column by column. Okay, so we'll see this in this thing in a MATLAB. Okay, so let's go to the array multiplication. So multiplication of vector, we'll start with the multiplication of vectors. Okay, so now we'll create a vector 1. Vector, let's say A is equal to 1. We'll create a column vector 1 2 3. This is the column vector with 4 elements. Okay, then there is a vector B, that is also a column vector, let's say 5 4 7 3. Okay, of same size. There is a vector C, okay, of now this will be a row vector. Sorry, this will be a row vector. Now what will be the row vector? Let's say 2 comma 5 comma 8 comma 4. Okay, now we'll try to multiply vector A and vector B. Okay, so multiplication, I'll write multiplication is equal to vec A star vec B. Now what will happen? Let's try this thing, and it gives an error. Okay, so it gives error because these elements are both the vectors are the column vectors, and this is of, let's say, one row by 4 columns, and let me add this comment here, and this is of 1 by 4 vector. So we want, if you want to multiply it, we want this to be the second vector to be 4 by 1. So this is 4 by 1. Now you can see here, sorry, this is 4 rows 1 column, this is 4 rows 1 column, and this is 1 column 4. What I'm doing, this is 4 rows 1 column. Okay, this is 4 rows 1 column, and this is 1 row 4 columns. Okay, correct. So if we have to multiply this, we must have this 4 by 1 multiplied by 1 by 4, and we'll get a single element, a single scalar value. Now if I have replaced this B with C, and now let's see what happens. Now you can see here, we'll get a, I said that we'll get a scalar value, but this is 4 by 1 and 1 by 4, so we'll get 4 by 4 matrix. Each element will be multiplied with this all the rows, so we'll get this thing. This 2 will be multiplied with this thing, this 3 will be multiplied with this thing, so this is 4 8 6 2 4 6 8 5 10 15 20 like this. So we got this 4 by 4 matrix here using the vector multiplication. Now if we do this thing reverse, so this will be C and this will be A. Now I'll multiply this thing and we'll get a single scalar value. So that was that's what I was saying earlier, that this will get a single scalar value as this is now becomes 1 by 4 into 4 by 1. Okay, so that's the vector multiplication. Now we got error here when we try to multiply vector A with a vector B, but this is possible with a dot product. Now how to use this function? Let's say dot product. If you have to multiply two column vectors, then this is dot, this is the solution, vec A comma vec B. Sorry, this is B. Now if we'll try to run this thing, we'll get a dot product. So if we have both the column vectors or both the row vectors, then also you can perform a dot product or multiplication, but you have to perform it as a dot product. So what it will do, it will take this one vector A, it will convert to the row, and this will this will remain column vector, and then it will convert. So if you want to try this thing, it will give a same answer. Okay, what we will do, vector dot multiplication dot. What you have to do, we have to use this A, we have to use this B, but we want A as a transpose, and if we run this thing, you can see here vector multiplication dot product is 46. So in this dot product, the vector A is converted to the row vector and then it is multiplied. Okay, now let's go to the non-square matrices. We have to generate few matrices. Let's say A is equal to, we do it for 2 comma 3 and 3 comma 4 and 5 comma 6. This is the matrix A and B. Now if we have this 3 by 2, we want a 2 by 3 matrix or 2 by anything. So 2 comma 3 comma 4 and 5 comma 6 comma 7. So these are the A and B. Now if we want to multiply non-scalar multiplication, square is equal to A star B. So if we run this thing, you can see here. So it was the A was 3 by 2 matrix and B is 2 by 3 matrix, and we will get 3 by 3 matrix after the multiplication. So this is how non-square matrices can be multiplied. Okay, now square matrices, it's very simple. We'll multiply this two, let's say A and C. Okay, matrix, or I'll write it square multiplication. Square multiplication is equal to control V, and that's it. Now I get this multiplication, so this is the value. Now what we'll do a reverse thing. Multiplication, a reverse order, and we'll just replace the C and A here. So we have this thing now here. So you can see here, we multiply A with C, this is the answer, and we multiply C with A, this is the answer. So both the answers are different. Now what does it means? That multiplication is not commutative, that we can not say, or it is not A star B is not equal to B star A. So this is the this one characteristics of matrix multiplication. And if you want to multiply a scalar, it's similar to the that's addition or subtraction, scalar multiplication is equal to 3 star, or we'll do it with A. So you can see here A was 2, 3, 3, 4, 5, 6, and it is multiplied with 3. So this is how matrix multiplication works. Now how we can use this matrix multiplication or array multiplications to solve the real life problems. One of the example is that the system of linear equations can be represented as a multiplication of matrices. So let's say we have this equations 2x plus 3y plus 6z is equal to 10, 5x minus 6y plus 4z is equal to 3, and minus 7x plus 5y plus 8x xz is equal to 4. So this is the system of linear equations. We can represent this in the form of ax into b, where a becomes the coefficients of x, y, z in the form of rows, and this x becomes x, y, z, column vector of x, y, z, and b becomes column vector of the right hand side terms 10, 3 and 4. So if you want, I'll execute this thing. Now what I will do, I'll change the names here. This will become, let's say, AA, and this will becomes BB. So this will also become AA and BB, because I want these names to be A and B here. So this will become A here. Okay, now what's the problem here? This is the problem. That's it. Okay, so you can see here, right, I think it will also give an error because the function x, yeah, these are the symbols. So so what you can do, you can do this thing for a timing. This is not the correct way to write those, but let's do it. Okay, so we have this x, now we want to see those. So you can see here, so this a is nothing but x, this is 2, 3, 6, these are the coefficients of x, y and z in equation 1, then equation 2 and equation 3. So in this case we have this as a column vector x, y, z, and then we have b, that is a column vector of right hand side terms. So this is how multiplication can be used to solve the real life problems. So in the division section array divisions, we will see how to use this matrix multiplications. Okay.